Hello everyone, myself Dr. Ashalata KS. Now we shall discuss about length of the perpendicular from the pole to the tangent and some problems. First of all, we'll find the length of the perpendicular from pole to the tangent. Okay. So let P of r comma theta be any point on the curve r equal to f of theta, and let OT be the length of the perpendicular from the pole to the tangent at any point P on the curve. We'll represent this OT, that is length of the perpendicular, by small p. Now consider the right angle triangle OTP. Okay, so from this find out sin pi. What is sin pi? Sin pi is nothing but opposite side by hypotenuse. That is OT divided by OP. OT is represented by P and OP is represented by R. So you will have P divided by R. Now cross multiply this, you will get P equal to R into sin pi. This is one of the form of length of the perpendicular, that is P equal to R sin pi. While solving the problem, we are going to use this result also. Okay. Now take the reciprocal of this equation. It's 1 by P equal to 1 by R sin pi. Now square that equation, you are going to get 1 by P square equal to 1 by R square sin square pi. But what is 1 by sin pi? It's nothing but cosecant pi. So you will have 1 by R square into cosecant square pi. We know the formula for cosecant square pi. It is nothing but 1 plus cot square pi. 1 by R square equal to 1 plus cot square pi. Again, cot square pi, in order to find out cot square pi, we know the angle between the radius vector and the tangent is given by tan pi equal to r into d theta by dr. Now take the reciprocal of this equation, you will get 1 by tan pi, which is nothing but cot pi, which is equal to 1 by r into dr by d theta. Now substitute that value here. You will get 1 by r square dr by d theta whole square. Okay. Now multiply this term inside the bracket. You are going to get 1 by p square, LHS 1 by p square equal to, after multiplication, this will be 1 by r square plus 1 by r to the power of 4 into dr by d theta whole square. So this is the length of the perpendicular from pole to the tangent at any point P of r comma theta on the curve r equal to f of theta. So while solving the problem, you have to remember this also. Okay. So in order to solve the problems, we will use this result as well as this result also. Okay. So we shall know one more form of the length of the perpendicular. So put 1 by r equal to u in the previous equation. If 1 by r equal to u, if we consider 1 by r equal to u, what is r? R is nothing but 1 by u. Now differentiate this with respect to theta. You will get dr by d theta equal to minus 1 by u square. Differentiation of this 1 by u is minus 1 by u square into du by d theta. Okay. Now substitute the value of 1 by r and dr by d theta in this equation. So you will left with 1 by p square equal to 1 by r is nothing but u. Therefore 1 by r square is u square plus 1 by r to the power of 4 is u to the power of 4, and dr by d theta is replaced by this value. Square this one, you will get this result. U to the power of 4 will get cancelled. Therefore 1 by p square equal to u square plus du by d theta whole square. This is the other form of length of the perpendicular. Now we shall solve some problems on this. First problem, Prove that the length of the perpendicular from the pole onto the tangent to the parabola 2a by r equal to 1 minus cos theta is a into cosecant theta by 2. Okay, so we have to find out the length of the perpendicular. As I already told you while finding the length of the perpendicular, so in order to solve the problem, either we will use this result and this result also. Okay, so in order to solve this problem, we will use this formula, that is P equal to R sin pi. Okay, so that means now we have to find the value of phi. Okay, so look here. Now from this curve, given curve, differentiate this curve with respect to r. Okay, so this is 2a constant. 1 by r differentiation is minus 1 by r square equal to 1 minus cos theta differentiation is sin theta. Since we are differentiating with respect to r, it's d theta by dr. Okay, so we want d theta by dr. Keep this and transfer the other terms to r LHS. You will left with d theta by dr equal to minus 2a by r square into 1 by sin theta. Okay, so now we have to find the value of pi, isn't it? So for that, we'll use the formula tan pi equal to r into d theta by dr. Okay, so we already find out what is d theta by dr. Substitute that value here. So r into minus 2a by r square into 1 by sin theta. Simplify this, 1r will get cancelled. So you will have tan phi equal to minus 2a by r into 1 by sin theta. Now observe the given curve. What is it? It's 2a by r equal to 1 minus cos theta. Now replace this 2a by r by 1 minus cos theta. Okay, so this minus sign will be as it is. 2a by r is replaced by 1 minus cos theta into 1 by sin theta, or it is whole divided by sin theta. We know 1 minus cos theta is 2 sin square theta by 2 minus as it is. What is sin theta? It is 2 sin theta by 2 into cos theta by 2. Simplify this. 2 will get cancelled. 1 sin theta also get cancelled. So we will left with minus sin theta by 2 divided by cos theta by 2, which is nothing but minus tan theta by 2. Now this minus tan theta by 2 can be written as tan of phi minus theta by 2, because this phi minus theta by 2 angle will be in the second quadrant. In the second quadrant, tan is negative. Therefore, the value of this is minus tan theta by 2 only. Okay, so which implies phi value is phi minus theta by 2. Now we have the length of the perpendicular is given by P equal to R sin pi. Okay, so which is equal to, what is R? From the given equation, cross multiply this. R is nothing but 2a divided by 1 minus cos theta into sin of phi value is pi minus theta by 2. Okay, so it's 2a divided by 1 minus cos theta into what is sin of phi minus theta by 2. This angle will be in the second quadrant. In the second quadrant, sin is positive. Therefore, it is just sin theta by 2. So, you will have 2a into sin theta by 2. And what is 1 minus cos theta? It is 2 sin square theta by 2, the formula. One sin will get cancelled. It's a divided by, and again 2 will get cancelled here. It's a divided by sin theta by 2. So which implies the length of the perpendicular from pole to the tangent is given by, what is 1 by sin? It's cosecant. Therefore it is a into cosecant theta by 2. Now we shall solve one more problem. So for this curve, show that for the curve r equal to a theta, show that the length of the perpendicular P is nothing but r square divided by square root of r square plus a square. Okay, differentiate the given curve with respect to theta. So you will get dr by d theta equal to a. Now we know that the length of the perpendicular is given by this formula. So directly substitute the value of dr by d theta here. So it will be this much. Now simplify this by taking the LCM. It's r square plus a square by r to the power of 4. Now take the reciprocal of this. You will get p square equal to r to the power of 4 divided by r square plus a square. Now take square root on both sides. You will get the result as p equal to r square by root of r square plus a square, which is the length of the perpendicular.